Hey guys, we're back for more math. It's a Wednesday for you now. Hopefully you did a good job getting through the submission for the last lesson, which was about just estimating fraction, sum, and differences using those benchmarks, getting us comfortable with the visuals and using the number lines. What we're going to get into today is some work on finding common denominators and then equivalent fractions, and that's going to kind of set the stage for us to be getting into the work we're going to do with adding and subtracting fractions later on in this unit on fractions, okay? This is a big one to help us understand how we can actually start adding fractions that may not have common denominators to begin. Like I mentioned earlier in the week, last year you were adding fractions and finding equivalent fractions, but the fractions you had already had common denominators. In this 5th grade material we're going to learn about, we're not going to always have those common denominators, and we have to make common denominators in order to add the fractions. Again, we'll get into those rules a little bit later next week. But basically what we're going to do today is work on how we can find equivalent fractions that will allow us to have common denominators, which down the road will allow us to add and subtract these fractions pretty easily. So this is like a kind of a setup lesson to be able to do the big stuff we got to do later on. Okay, so real quick, before we actually start getting to the page, we are going to start on page 369 as far as the book is concerned. But what I want to look at first is just a little visual again with some fraction. Now this is just an easy peasy fraction. We all know what this one is. This is one part shaded out of 2 whole parts. So of course what we have here is the fraction representing 1/2. Okay, so here if I write down here, 1/2 here is written like this: 1/2, 1 part out of 2. We have our numerator and our denominator. Let's go ahead and make sure we've got those terms here: numerator, denominator, and of course fraction line in between here for us. And this is again just to get into some vocabulary and help us see these a little bit better. Numerators and denominators. Okay, so there we go with that numerator, denominator. Now, if we talk about equivalent fractions, equivalent means equal, means the same amount, okay? We can write our fractions in a different way using different numbers that still represent the same amount. So if I do like a quick and easy one, I might have, let's say, if I draw a line between here, I'm going to kind of split this up into smaller parts, but it's still the same amount shaded. Notice here we've got this half of a circle shaded in. Same thing here, half of a circle shaded in, but what I've done is I've changed it a little bit by putting in some different amounts now. Now I've got 2 shaded parts out of 4, but again, it's still equal to 1/2. I didn't change how much is shaded, I just sort of changed how I split it up. So with this one, what we can say is our fraction in this case is 2 parts out of 4, and this is 2/4. So these are equivalent fractions. 2/4 is equal to 1/2. Okay, and again, we can keep going with that again just to kind of keep the visual stuff going. I can start off, here's 2/4. If I continue splitting into equal parts, I can go like this, and now I've got, again, still the same amount. I didn't change how much I have shaded. It's still the same total amount shaded. It's still equal to 1/2, but now I've got 4 parts shaded out of 8 total parts. So I've still got the same whole amount. I just represent it differently based on how many pieces I chop it into. Okay, but again, there's still the same shade. I didn't change how much green is on our image. I just split it up into different amounts here. Okay, so again, this is how we can work with these equivalent fractions. And then this would, of course, be 4 parts shaded out of 8, and this would be 4/8. Okay, now the way I did this visually is just to cut it up and split it up. What we're going to work on today is how we can go from one equivalent fraction to another just by numbers. And notice here, if I go from 1 to 2, I would multiply by 2. If I go from 2 to 4, I also multiply by 2. So what we'll find is if we multiply our numerator and denominators by the same amount, the fraction amount stays the same, okay? By the same token, if I go from 2, let's say over to 8, how much do I multiply to get from 2 to 8? 2 times 4, right? 2 times 4 equals 8. And then the same thing here. If I go from 1 to 4, I multiply by 4, and I get 4. 4/8. 1 times 4 would be 4. 2 times 4 would be 8. So that's one way we're going to work on to get ourselves some equivalent fractions using these common denominators. And the goal is to take two fractions that don't have the same denominator and then make equivalent fractions for each that end up with the same denominator. And that's our big thing today. Okay, so let's go back to the textbook page. And we've got this example of a person with a garden, and basically what we want to do, I'm just going to kind of jump down to this part. We want to find a common denominator for 1/3 and 1/4, or equivalent fractions with a common denominator. Okay, so one thing we can do is multiply those denominators. We'll kind of see that as we go through. If we multiply 3 times 4, we would get 12. In this case, that can be a common denominator. We can always multiply the two denominators together, and whatever product that gives us is going to be an equivalent fraction we can make that has a common denominator. So to do this visually, here we have our thirds, and let's just go ahead and fill in one of them. Let's say we have 1/3 here, and we're going to split it into 4 parts. In the example here, it says divide each 1/3 into fourths. And then, so the way we can show that is just by splitting up into fourths here. When I do that, again, this is like a visual way of looking at it, just like I did with my picture of the circles. But here, I took what was 1/3, and now I made 12 equal parts. And how many are shaded? Just like the circle example we did. Well, there's 4 out of 12 shaded. So we can say that 1/3 is equal to 4/12. Fill that in here. Okay. Now I can do the same thing. Just like we said when we multiply our numbers together, if I go from 4 to 12, I need to multiply by 3. So here I have fourths, and if I shade in 1/4, let's do a different color. If I shade in one of these fourths, here's the amount I have, and then I need to split this to make 12 equal parts. I would split each section into 3 more parts. So I'm not going to do 4 again. Again, the goal is to end up with the same amount of stuff every time. So I'm going to go ahead and do this way. When I split like this, again, just like when I split up my fraction amounts here, I didn't change how much is shaded, I just kind of changed how many parts there are. It's still the same total amount, and that's what we're kind of looking at here, okay? So now if I had 1 out of 4 shaded, now how many, there's 12 total pieces, and how many are shaded here? Well, we see 1, 2, 3, okay? So now we can say that 1/4, if I split it into 12, so again, just like my circle example I just did, that would be equal to 3 out of 12 being shaded. So we can say 3/12 will be equal, okay? So here, just a preview, is a way I can actually add these. Again, when you worked on adding fractions last year, you couldn't do it unless you had common denominators. Now in 4th grade, they just give you those common denominators. But now what we're going to do is work on making common denominators by taking equivalent fractions. So again, notice here, when I had 1/3, that's the same as 4/12. I didn't change how much I have. I just sort of changed the way I show it by splitting it up into small bits. Still the same amount of red stuff here. It's just instead of 1 out of 4, it's 4 out of 12. Same thing with this. Same amount of blue. I didn't change how much blue is shaded in. I just split it up into smaller bits into 3/12. So now what I could do is I could actually add these together if I wanted to. Instead of saying 1/3 plus 1/4, I can say 4/12 plus 3/12. I can add that together. And again, you might think from last year I did, well, I know 4 plus 3 is 7. And then the trick with these is the denominator stays the same. This is just telling us how many parts we have, okay? How many total parts. We're going to keep that 7/12. Again, we'll get to that a little bit next week, but that's the idea, okay? Once we have common denominators, because that's the rule, if you remember from 4th grade, you didn't add those denominators, those stayed the same. As long as we have the same denominator amount, we add that top, the numerator, and then we can keep working, okay? So that's a good way to do it, and that's what we'll get to. Again, this part of actually adding them together, we'll get to next week. I'm jumping ahead a little bit just to preview, but for now, we're just going to work on taking these fractions and rewriting them in an equal way, the equivalent amount, the same amount. Again, remember the visual picture is the same amount, it's just differently written a little differently so we can see a little bit of a different way, okay? Now, just like our last lesson, eventually we get to working with just the numbers. And again, that's kind of the big thing with 5th grade and beyond as we work with our numbers more. Here, another thing we can do is make a list of the first 8 non-zero multiples of 3 and 4. So what that means is basically let's list our multiples. So it starts off with 3, 6, 9, and then we can, of course, go 12. Then what would be next going by 3s? 15, 18, 21, another 3 would be 24. Okay, so there we start off like that. If we go with our going by 4s, they give us 4 and 8, and then we can go 12. Another 4 would be 16, 20, 24, 28, and then eventually 32. So when we do this, we can actually find numbers in common. So it says circle the common multiples when we do that. So that would be the numbers that they have in common, right? The ones we see appear in both lists. We have 12 and 12. We also have, what other ones do we see that match up? Well, if I look through, I see here's a 24 and here's a 24. These are other common multiples. So there's always more than just one if we list out enough. What we're going to work on is finding what's called the least common multiple. That's going to help us find our equivalent fractions usually in simplest form if we use that least common multiple. So that would be this one in this case would be our 12, okay? So 12 would be our least common multiple. Then what it says is this: use one of the common multiples as a common denominator to write equivalent fractions for 1/3 and 1/4. Now again, just like we practiced on this, I pointed out, if we practice on this, when we go from one number to the next, we multiply. If we multiply by the same amount, we'll be able to work those out quickly, okay? So here we can say our 12ths are what we're going to use. Do 12ths. Now think of yourself, okay, how do I get from, if I go from 3 to 12, I can make an equivalent fraction. If I go from 3 to 12, I would say 3 times 4 makes 12. So 1 times 4 is 4. Again, I got to do the same thing for top and bottom to make them equal. I do the same thing to both. It stays equal amount. If I go from 4 to 12, 4 times 3 would be 12. And so I have to do the same to the top. 1 times 3 to change my numerator would be 3. Okay, so there we have that. So you notice we're doing the same thing as what we did up here. It's just a different way, kind of using the number lists. Okay, all right. I'm going to go ahead and jump into another one, onto our next page, 370, where we're using fourths and sixths. Okay, so here it says find our least common denominator. Least common denominator is what we're going to be working on. We're going to list multiples of 4. So we can start off by saying 4, 8. Go by 4s, 12, 16, 20. Great. Okay, if I want to go down to doing multiples of 6, I can do 6, 12, 18, 24, 30. Okay, I can keep going. But notice again here we find a common denominator. What's our common denominator? We see there's a number in common. What's the first number in common is always going to be that least common denominator. Again, in this case, it's 12 once again. Okay, 12 here, 12 here. So they have 12ths in common. So we can say the least common denominator is 12, and we can work with that to find equivalent fractions. Now again, down here it says using the least common denominator, write an equivalent fraction for each fraction. So notice here we're doing the same strategy. From 4 to 12 we would multiply by 3. Now again, we want to have that 12 as our common denominator. And in this case we have 3 already for our numerator. So if I go from 4 to 12, I multiply by 3, as they point out here. 3 times 3 is going to be 9. So this would be your equivalent fraction of 9 there, okay? Now again, down here, if I'm going from 6 to 12, let's fill in the blank. What do we multiply to get from 6 to 12? Well, we'd multiply by 2, right? So we're going to multiply by 2 there, and we have to do the same thing up top, and now we've just got some math we need to do. 1 for our numerator, 1/6 would be equal to 1 times 2 would be 2, and 6 times 2 would be 12. So there we've got 2 equivalent fractions that we can actually work with. Now we've got common denominators. So again, the goal is to take these fractions 3/4 and 1/6, and eventually for us to be able to add those up, we need to find common denominators first. So what we do is find equivalent fractions. 9/12 is the same as 3/4. 2/12 is the same as 1/6. But now what I've done is I've got 2 fractions here that have common denominators. So your goal today, as you work through some problems, is going to be to find the common denominators versions of equivalent fractions, okay? So if we do this next one, let's think about the denominators for a common denominator for 6 and 9. Our common denominator is going to be 18. We can go 6, 12, and then 18, or if we go by 9s, we get from 9 to 18. That's our first number they have in common, so that's going to be our common denominator here, okay? So let's talk about that. If I fill in 18 here for each, think about how do I get from one to the next. So now I'm talking about from 1/6 to 18ths. How do I get from 6 to 18? Well, I multiply by 3, okay? 6 times 3 makes 18, so then I have to do the same thing up top. 1 times 3 is going to give me the equivalent fraction. 1 times 3 is, of course, 3. Okay, and then 1/9, how many 18ths? 9 times 2 would make 18, so 1 times 2 makes 2. So there's our equivalent fraction. All right.